This is the MohrCircleHelp video for structural geology. So in structural geology, you might be asked to do the following things with a Mohr circle. You might be asked to find the orientations of principal planes or plane stresses. You might be asked to find the principal stresses, and you might also be asked to find tau max, which is your maximum shear stress, and the normal stress that goes with it. So first, I just want to touch on some basic things. When you start these problems, you want to have axes set up where your y-axis is the shear stress and your x-axis is normal stress. And you need to also make sure that you include units. You need to have these three formulas stuck somewhere in your head, and they'll make more sense in a little bit. One is the average normal stress, and that's going to be the plane stress in the x direction, and the plane stress in the y direction divided by 2. So it's an average. You need to have this one stuck in your head. This is R, and it'll make sense in a minute why we say R or radius, is the difference between the two plane stresses divided by 2 squared, plus whatever the shear stress you're given is squared, and then all that square rooted. And then tangent of the angle, so the orientation of the principal planes, is 2 times your shear stress divided by the difference between your normal stresses. So those are going to be worth writing down. So really quickly, when you draw your axes, if all the stresses that you're given initially are in tension, meaning they're negative, then your Mohr circle is eventually going to fall on this left side, the negative side of the y-axis. And if you, of the x-axis, if all of your stresses are positive, then you're going to be in compression and you're going to be on the positive side of the x-axis. And if you have some combination of positive and negative stresses, you're going to have part of your Mohr circle on the negative x and part of your Mohr circle on the positive x. So let's start out with a way that you might be given a problem. So you might be told that you have sigma y equal to positive 10. And it's positive, we know it's positive because those arrows are pointing in, it's compression. You might also be told that you have a positive sigma x that's 50. And these are all in megapascals. Again, positive because it's pointing in. And then you might be told that you have a tau or a shear stress of 40 megapascals. So I'm going to draw it in like this. So tau xy of 40 megapascals. And again, you might be asked to answer those questions that we laid out earlier. So the first thing that I'm going to do is I'm going to find the angle for those principal stresses, or the orientations of them. And so I'll go down to my kind of scratch work area down here, the problem that you're given, and you might be asked to find your principal stresses. Now you might be thinking, well, these are pointing really directly at that square or the box diagram. Why isn't that a principal stress? Well, a principal stress is going to be something called sigma 1 and sigma 3. That's what we're going to plot on that Mohr circle. A plane stress is going to be sigma x or sigma y, and these are going to help you find those principal stresses. So let's go ahead and first find the orientation of the principal planes. So I'm going to use the equation up there with tangent. I'm going to do tan of 2 theta is 2 tau xy divided by sigma x minus sigma y. 2 tau is going to be 2 times 40, so that's 80. And sigma x minus sigma y is 50 minus 10. So 50 minus 10 is 40. And those are both in megapascals, so the units there are going to cancel, and I get 2. So now I have tangent of 2 theta equals 2. Don't divide by this 2 just yet. Don't get too caught up in that. We've got to do arctan. So arctan, or inverse tan of 2, is 2 theta. And you'll go to your calculator, make sure it's in degrees, and say inverse tangent of 2, 63.43. So 63.43 is 2 theta. And then you're going to divide that by 2 to get theta. So here, theta is 31.715. Now, remember that you need to get 2 numbers here. And the reason why you need to get 2 numbers is that you have 2 principal stresses that you're trying to find the orientation to. So this might be the orientation to the first principal stress, and then to the second one, you're going to add 90. Because the principal stresses are always oriented 90 degrees to each other. So 31.715 plus 90 is 121.715. And those are both in degrees. So those are your orientations. So if I had to go back and say you get asked to redraw this box diagram, then what you're actually going to draw is something that looks a little bit different. So you're still going to draw in kind of an X and Y plane, and then you need to take your protractor and measure up 31.75, and let's say it's right there. Then what you're going to do is draw one side of your box diagram rotated that way. Draw your others. And then what you'll find if you draw this 90 degrees over, that's actually going to be that 121.75. Okay, so let's see. Ooh. We know we're in compression, so our arrows are going in. And we can say that this one is going to be whatever the maximum one is, the maximum principal stress, and that one's going to be the minimum. Okay, so that's how you get those angles. The next thing you might be asked to do is actually find what those principal stresses are. And so to do that, again, we come up here, and I did not give you the formula for them, but that's okay. So to get the maximum principal stress, you're going to do the average plus the radius. To get the minimum principal stress, you're going to do the average minus the radius. Be asked to find are your principal stresses after you found the orientation to those principal stress planes. So to do that, you're going to take the formula for your average normal stress, and you're going to take the formula for R, and to get sigma 1, you're going to add those two together. And to get sigma 3, you're going to subtract them. So here I did just that. I did sigma x, remember, was 50, sigma y was 10. So 10 and 50 is 60, divided by 2 is 30. Over here I subtracted them, so I got 40 divided by 2 is 20. 20 squared was 400. And tau was 40, so 40 squared is 1600. I took the square root of 2000, which is those two added together, and I got 44.72. So sigma 1, again, I'm adding these together, and I get 74.72 megapascals. And for sigma 3, I'm subtracting them, and I get negative 14.72 megapascals. And here's an important point. Sigma 3 is negative, and sigma 1 is positive. And so that means when we go to plot this thing on a Mohr diagram, or as a Mohr circle, we should expect it to plot partly in tension and partly in compression. Now, if you remember over here when I drew this, you might have thought, hey, all these arrows go in, so we're always going to be in compression. But the truth is that a Mohr circle just represents a series of combinations of sigma x and sigma y. And so you may have one particular orientation where sigma x and sigma y can both be positive, but for your principal stresses, they're not both positive. Okay, and here this is just slightly negative compared to this being really positive. So let's go ahead and plot this and just see what the circle looks like. So I'm going to go up to my axes, which are of course labeled because that'll be worth some points. And just for now, I'm going to make tick marks that aren't exactly perfect. So 1, 2, 3, 4, 5, 6, 7, 8, and I'll say each one of those tick marks is 10 megapascals. It's really important for you to give that scale. And on the negative side, I'll go 2 down. Okay, so we know that our sigma 1 was 74.72. So I'll come out here and say it's going to plot about right there. And I'll label that sigma 1. And I know that sigma 3 was negative 14.72. That's going to plot about right here. And I'll label that sigma 3. Okay, so now an easy thing to do to be able to plot this Mohr circle all together is to find the center point. So I'm just going to average sigma 1 and sigma 3. So negative 14.72 plus my other one was 74.72. And I'll divide that by 2. Oh, it's 30. That's right, we knew that because we calculated it down here. So I'm going to come over to 30 and put a point. And I'm going to label this a sigma with a little hat, just to show that that's an average. So now what you're going to need to do is use your compass. And so you put your pointy end on your average and stretch the pencil end out until you get to sigma 3. And then go ahead and make your arc. I'm going to set the camera down for just a second.